Lesson 10.3 looks at shapes of distribution. So our essential question is, how can you describe the shape of the distribution of a data set? So some of the vocabulary that we're going to be looking at, one of them is the word skewed, and that is something that has a slanted direction or position. So if you look at pictures down here, we've got a picture of a tree, might be on a wall. It's not skewed, it's straight. Over here, like you bumped into it, and now the picture's skewed. It has a slanted direction or position. Okay? So we're going to be using this terminology when we're talking about shapes of distribution. When you hear shapes of distribution, the question is not looking for a shape like circle, rectangle, things like that. Okay? They're looking for if something is skewed or not, if it's kind of slanted or not. Okay, so when you're talking about shapes of distribution, most of the time you're going to be dealing with dot plots and histograms to identify the shape of distribution. You also can talk about distribution with box and whisker plots, but we're going to be talking about those soon. But today we're just dealing with dot plots and histograms. So here's some examples down below. This first graph has a graph that's skewed left. Okay, that means in this histogram, if you drew a hill over your data, the tail, or the long stretched out part, is over on the left-hand side of the set of data. So that shows that the shape is skewed left because the tail is on the left-hand side. This also means, if you look down here, that most of the data are on the right. That means that where the highest points are over on the right. That makes the tail go down, stretched out to the left. Okay, so if you have the shape of distribution that's skewed left, most of the data is actually on the right. You can have a shape of distribution that's symmetric. That means that the left-hand side tail looks the same or almost the same as the right-hand side tail, and the peak is typically in the middle for that one. Okay, so symmetric. When you do your hill, the peak's in the middle, and it's the same stretched out tail on the left and the right. Over here is an example of a shape of distribution where the data is skewed right. So when you draw your hill, the tail stretches out to the right-hand side. Okay, so this is skewed right. That's where the tail is, on the right-hand side. This also shows that most data are on the left. So now we're going to go ahead and practice this ourselves. So if we were asked to describe the shape of distribution, down here is the number of touchdowns. So I draw my hill over my data, and I find that the tail, the stretched out part, is over here to the right. So this is skewed right. Okay, this one, if we draw our hill, looks pretty much the same on the left. It is on the right, so this one would be symmetric. Okay, over here, and I find myself, I usually start my hill closest to the peak and then draw it out. So the last thing I usually do is the tail, unless it's symmetric, and then you can start on either side. So if the tail is stretched out part, it comes down to the left, it means that this data is skewed left. Okay, this one, when you do this up there, and then down here, it's not identical, but it's pretty darn close. So your peak is in the middle there, and it drops down fairly close, similarly on the left-hand side as it does on the right-hand side. So that would make this one symmetric. Okay, over here, we've got inches of rainfall. There's our peak, stretches out down here. So my tail is on the right-hand side. It's skewed right. Over here, stretches up to the peak, stretches down. My tail that extends out is to the left. So it's skewed left. And the last thing that we're going to do is put it all into action, where we are going to create a dot plot using the data shown below of cups of water per day, and then describe the shape of distribution. So we'd start with our number line, because dot plots have to be on a number line. Our littlest number is a 5. Our largest number is an 11, so it's not a huge range, so I can count by ones. And they will all fit nicely on here. Getting too excited to write the number 11 there. All right, let me erase that one. All right. Below it, you want to give it the title. Okay, cups of water per day. So don't forget to title any graphs or plots that you do. And because it's a dot plot, we need to make sure we include dots, not X's. If you do an X's above, you're actually creating a line plot. So dot plots have the dots. If you count up here, we have 1 5. Okay. There's 2 6s. There are 1, 2, 3 7s. Okay. There are 1, 2, 3, 4, 5, 6, 7, 8. There were 8 8s. 1, 2, 3, 4, 5, 6, 7, 8. 9s. 1, 2. Missed one somewhere, I think. 3. There it is. There's 3 of them. 10. 1, 2. And there's 1 11. So when you do your hill to look at your shape of distribution, the peaks in the middle and the drop downs on the left and the right are fairly similar. In this case, they are identical. So that makes the shape of distribution for this one symmetric.